Dear students, I welcome you all for the online learning pertaining to the course Warehousing Automation. So we are in the process of learning this course through online platform, and coming to the syllabus for the first unit, there are total 11 chapters are there, where I have just divided the 10th chapter into two: picking and packing robot separate and layouts is separate. As of now, we have finished for the first 9 chapters. We have finished for the first 9 chapters, and now in this presentation, we will be discussing about picking and packing robots role in a warehousing automation setup. How it can be used, what is a robot, and how it can be used in a particular way. Now, this was the earlier discussion what we had. Now, we knew what is inbound logistics, we knew what is outbound logistics. Now, our main focus lies with respect to intra-logistics, that is the logistics activity within the warehouse, only within the warehouse, with respect to storage as well as with respect to picking and packing. So this is where we are discussing. So in this regard, we discussed about carousels, how carousels can be used. We discussed about shuttles, then cranes, then conveyor system. So as of now, we have discussed on the last part, that is with respect to physical process automation. The last concept is picking and packing robots. That's what this particular presentation is going to take us through. So earlier presentation, we discussed about conveyor systems, where warehouse conveyor systems are very simple to use. The platform is static, only there is going to be a belt or some other movement which is going to take the product from one end to another end. So this was the thing what we discussed, and of course we discussed about different types of conveyors which are employable in a warehousing case. And the main advantage here is they are very simple to use. It's going to have a platform and the width can be suitably modified. And the other important thing is, for various natures of products, for the various nature of the material, so different types of conveyors we discussed. But the advantage here is they are easy to do and it is easily reconfigurable. We can reconfigure. So there are several advantages what we discussed. They are used for continuous sequence, one after the other. Series of products can be transported in this regard. Now coming for the disadvantages, they can't be used for perpendicular joints. When we wanted the product to transport from a perpendicular part, from the axis of direction, we just wanted to take a right turn or a left turn perpendicular exact 90 degrees. No, these conveyor systems are not capable enough. However, some arc it is possible. We can take the perpendicular thing, that is right angle, but exactly by means of an arc, not by 90 degrees. So this is therefore, conveyor systems can't be adopted for some cases. Okay, all the cases conveyor systems or shuttle or whatever the earlier material handling systems pertaining to the physical process automation is not possible. So therefore, we come for another newer category, of course, a quite advanced feature called as robots. So basically they are employed for the case of pick and place because it is confining to warehouse cases, not for painting application, not for welding, or not for any other activities. So here in an automation case, so robots are employed only for pick and place. So pick and place are very commonly used in modern manufacturing environments. Now we should understand one particular thing. What is the role of robot in a modern manufacturing process or an environment with respect to warehousing cases? See, the same pick and place activity is also being carried out in a manufacturing case. For example, we have got a machine, say CNC machine. There is a material being available on one end and a finished product is being stored on the other end. Now, often this particular product has to be loaded onto the machine. Upon completion of machining, again the finished product has to be unloaded. Now, human can be used in this particular case, but we knew the fundamentals of automation, where we are going to adapt some sort of technologies or adopt some sort of technologies which is going to minimize the human intervention, especially for repetitive tasks. So this is a repetitive task. Now a robot with the appropriate tool, end of arm tool, will be employed, and this case is called as machine tending. T-E-N-D-I-N-G, machine tending. So here it is in a manufacturing case, that is how robot is used. Now the same case we are going to camouflage it for the case of warehouse automation. So it can be used for the case of in a very speed up case, that is a human can't do in a very faster case, but robots are capable to do so. They can used for picking up of parts or items and place them in particular order in a particular fashion. This is what very important is all about. It is not going to mere place, it is going to organize. This is what the advantage, or this particular advantage helps us to adopt robots, pick and place robots in a warehouse case. Now when we automate the process, what obviously increases is production rate. Yes, obviously production rate is going to increase with respect to time, and therefore we are in a very comfortable position where the efficiency of the warehousing case is going to improve. So pick and place robots handle repetitive tasks while freeing up human workers to focus on some other complex work. So just for mere picking and placing, we need not to depend upon human. Of course they are susceptible for fatigue and they are prone for errors. Now that can be easily overcome. So usually how these robots are used is, see, the robot level might be different and the working environment level might be different, in the sense altitude. I'm talking about the altitude. Now easily it can be compensated. How means we can have a pedestal, we can have a stand, a fixed stand. Okay, it is going to act as a platform above which the robot can be positioned, and further programming can be assisting in order to do the task of picking and placing at a very precise point. At an accurate case, yes, we will be able to do it. So they use advanced vision systems. Some cases, not all the cases, even machine vision systems can be adopted for the case of sorting. So now there might be a doubt, what is this machine vision? So machine vision is none other than fitting up of cameras, and this camera will give some sort of input to the robot for the case of sorting. One simple example is, we just wanted to sort color based on color. Black color products, box somewhere else, a red color somewhere else, green color somewhere else. Likewise, if you are having boxes, robots do not have eyes. Therefore, they are not in a position to do this task. On the contrary, when we fit a camera, smart camera for it, and appropriate programming is done, then now the robots are capable to pick and place. That is, they are in a position to sort based on the color. So this is one thing. That might be geometry or size, whatever thing. Based on the nature of the program, it is possible to do the task. Now, how will it hold? This is what very important is. How a robot will hold. So for that, at the end, that is at the tip of the robot, we have one particular specified element called as EOAT. EOAT, end of arm tooling. So this is what very crucial is. As such, robot is not so versatile to pick or to place. So grasping action will be there, releasing action will be there. So this end of arm tooling, how a human has fingers, likewise robots also can be fitted with some sort of EOAT. Now let us go with simple examples. Now we have got a job to be picked up. For that, somewhere like 2 fingers are sufficient. Let us take this particular case. Yes, 2 jaw grippers are there. So similar to human hand, 2 fingers, 2 jaw grippers. 3 jaw grippers are also there. Or if it is something like a delicate item, we can go for suction grippers, vacuum grippers. They will suck. This is the surface, means on the surface the suction cup will grasp everything and it is going to release as such. Even there are interesting programming tools are also there. Even automation students, they will be carrying out a laboratory course by name Factory Simulation Laboratory, where such programs can also be done. Of course, mechanical will be doing in their 7th semester, but automation will be doing in their 6th semester. So as such, robot is not capable to pick or grasp or release any of the products, but based on the EOAT, it can be done. Now let us deviate from the topic. That is, on a generic case, let us see. Not for warehousing context, some other context. If a robot has to paint, so that painting gun has to be fitted in the case of EOAT. Now the robots are capable to paint. If the robots are fitted with welding torch, now they are capable to do welding activity. So some screwdriver or something we do, they can be used to tighten or loosen a screws. So likewise, robots are made efficient, especially based on the EOAT, end of arm tooling. So example we just discussed in the earlier slide itself. So I am skipping this. Now, types of robots. There are different types of robots are there, but now these types of robots what we are going to discuss henceforth are strictly filtered for the case of warehousing application. So there are different types of robots that you will be learning through robotics course, but here with respect to picking and place activity, especially in a warehouse case, what all other robots are available, only those robots are discussed. So the first is articulated joint robotic arm. In short, it is called as robotic arm. So they are the highly or super versatile robots which are used for the case of pick and place. They are they are specially integrated into the warehouse for the case of picking and place. So there are multi-axis are there. Similar to a human arm, there are multi-axis are there, say 5 axis or 6 axis. So similar to a human arm, it is going to mimic the working of a human arm. The same case, how a human arm is able to pick from one point to another, how we have got a wrist, how we have got an elbow, how we have got an arm. Similar to these joints, it is going to replicate the same and we can get multiple joints and they are going to be employed for the case of pick and place. Now we'll see their functionality. Because of this multi joints, they can twist. So the orientation of the product can be changed. The direction can be changed. Anywhere we can use it because it is having a flexible joints. So this is what a articulated joint or multi-joint robot is going to look like. So we can see at the base, this is the joint one which is going to resemble the hip of a human. So it can go for a twist motion. It can be used for twist motion, not complete 360 degrees. It cannot rotate 360 degrees, maybe 320 degrees or so. So for the case of twist. So this is joint 2. So it can go forward and backward. Likewise, all the joints can be used and easily we can accomplish the task of picking and placing inside a warehouse. Now the next type. The first type was robotic arm, that is articulated joint. The next is Cartesian joints. So we knew the Cartesian coordinates, that is there are 3 axes are there, x, y, z, and translation +x minus x plus y minus y plus z minus z. So there are 6 translation movements are there. So using this orthogonal axis x, y, z and the movements, we are getting 6, but everything in the linear cases. We have got only linear cases. So construction is very simple. Henceforth, we can use for certain applications, but we can't use the way how we use a versatile robots like the earlier one, like the farmer. No, but it is capable to do some interesting activities. So they are used for better accuracy. Why? Because when compared to 6th joint, that is 6 joint robots, what is the thing is accurate programming is little bit a tough part, but here it is very simple because we have got x, y and z coordinates. It is comparatively simple. So this is how a robot look like. Okay, so it's a gantry type of robot where we are getting support on all the axes. So it is going to mere pick and place from point A to point B. So the construction is simple, the operation is simple, the programming part it is very simple, no complications since we knew the coordinate. And the other interesting feature is we can use in a very fast case, rapid case, simple construction in a fast case. That is, pneumatic actuators can be used to linear actuators. Therefore, we can easily go ahead with the positioning. Then the next type, delta robots. See, delta robots are also known as lightning fast robots. See, there are some peculiar acronyms are there, that is, which correlates their functionality, something like an analogy. So for the case of articulated joint, we call it as super versatile robots. Then the second, Cartesian robots are positioning accurate robots. So they are used for such cases. And delta robots, often they are called as lightning fast. So they are the fastest robot across whatever the robot exists in the globe as on date. So delta robots are highly versatile enough, they are highly rigid enough, they can do in a very faster case. So that's the advantage. So disadvantage part, when you see, they can't lift heavy loads because the construction is of that nature. So we'll see the construction, the next slide. So it is very simple. There is going to be one base and there are 3 joints are there. So construction wise it is very simple, and like regular robots, which is not going to be mounted on the floor, it is going to be mounted on the roof. So it is going to operate from the roof, similar to a bat. How the bat is going to be sustained in an upside down category, this robot is also going to be in the upside down category. So this is how the robot is. So this is called as base, that is going to take in the roof part. So we are going to have a special frame that is going to take up the roof part. So now what is the advantage here is, it is not going to defy gravity. It is going to pick marginally, it is opposing the gravity, but while placing it is going to obey gravity. So that is one of the reasons why it is going to give a lightning fast activity. Then we can see the construction. The construction is very simple. It has got just 6 joints, top 3 joints and bottom 3 joints, and it is a simple pantograph mechanism. So where the base is mounted to the roof, so here it is mounted onto the platform, and easily it can pick and place in a very faster rate when compared to any other types of robots. So next, attributes. How to measure the functionality of a robot. So this we have used. This particular term we came across long back, SKU. That is stop keeping units. So robots should be in a fast case, where they should do in a very faster case than human. That is the ultimate objective. And the second objective is they are going to free the operator, that is it is going to save time. Therefore we can come out of the fatigueness and it is not going to do any sort of error. And the other important thing is, think with respect to the picking category. So usually 8 to 300 SKUs is possible. So from 8, based on the size, based on the volume of the product, from 8 to 300 it is possible when we opt a robot for the case of pick and place. Collaborative. So this is the last type. See, collaborative robot is, earlier robots we need to program everything in a very precise case. We need to program the start point, the end point, that is pick point and place point. But when we go for collaborative robots, it is made with a special memory category. So it is going to auto learn. Only thing is, as a human, we should teach the motion. Therefore, it learns the position thanks to the stepper motors and the memory facility being enabled into it. So based on that, it is going to pick and place. So this is all. So we have got a robot. So this robot will directly be, you can just hold the arm and we can go to one particular point, press a button, it is going to remember the point. No programming point. There is no programming option at all. Just teach the robot. This is your first point. Press the button. It will learn the point. Then perform grasp action. Then go to the next point. Keep it there and press another memory store button. It is going to store the point. Just do a trial run. Okay. If it is okay, then yes, you can directly go ahead with the program. So there is no external connection. It is going to learn the way how a human learns. So training alone has to be given, no complicated training, just position based activity, and we are going to teach at what position, what activity the robot is supposed to perform. So with these tasks, yes, it is easily possible for us to teach the robot, and that is where it is called as collaborative robot. Now, what all are the applications the robot is capable to do? So the first application is robots can be used to assemble. So we can go ahead with assemble, but in a warehouse context, assembly might be there in a very peculiar case. And general case is packaging. So packaging is going to be very crucial activity where it need to pick up the packing carton or the cardboard, then the part it is supposed to place within the part, and of course packing also can be done by means of a robot. Bin picking. So this is another case, the empty box or a complete box. So again it can be used, and even we can palletize. So palletize is stacking up of one over the other. So likewise even also it is used. Inspection. Yes, inspection is very essential. So before delivery, some inspection has to be done, whether packing is prompt, whether address from to everything is there or not. So usually using some advanced vision system, yes, it is done. Some cases it is checked for defect of parts. Any defective part has been there, any damaged part, anything is there. Yes, it can be used. But upon outbound logistics, if it is getting damaged, it is beyond the scope. But however, prior to the delivery, an activity called as PDI, pre-delivery inspection, will be carried out, and robots can nicely be employed in this category to perform the task. So now we are on the last phase where we are going to summarize the learnings what happened in this particular context. So in this video we just learned about robots, pick and place robots, especially in the context of warehousing automation. So three robots essentially we discussed, and the fourth was an advanced one. The first is articulated joint robot. In short, it is called as robot arms. So these robot arms mimic the human arm, and they are highly versatile in handling various types of picking and placing activity. And second was Cartesian coordinate. Cartesian coordinates is they are highly interesting for accurate positioning with respect to x, y and z axis respectively. And we discussed about delta robots, which is also called as or also known as lightning fast robot. Thanks to the construction, it is going to be upside down, it is going to have a base, it is going to have three joints, links, it is also called as parallel links, and it is going to work based on a pantograph mechanism. And final was collaborative robot. Collaborative robot is none other than an articulated giant robot where we are not going to use the robot for the case of programming. It is going to be taught. It is going to be trained for the case of picking and placing by means of memory application. Okay. And applications, it can be used for robots, can be used for assembly. Robots can be used for picking and placing, for packaging, for bin picking, and finally inspection. So for all these cases, robots can be used in automation for the case of warehouses, and definitely the operational efficiency is appreciably increased. Okay. Thank you, students. Please note down for the case of doubts. So we shall discuss the same in the offline class. Thank you.